Hello data nerds, what's up? Today we're going to cover an important topic of SQL, which is joins. It's super important, very useful, and Sai Mohan, if I'm not wrong, requested twice to cover this session, so I thought, why not do it? So here we are, Sai, and let's study joins today. Let's get started. So first things first, let's understand what are joins and why do companies need it, how many types of joins do we have, and which join does what. So let's clear these basic concepts first, and then we'll try to solve a few problems in later sessions. So the first and very basic question comes in everybody's mind, that what is a join? So the simple answer is that if your data is stored across multiple tables and you have a requirement where you want to pull the data from 2 or 3 tables or more than one table, then you use joins to retrieve data from multiple tables. So that's what join does in very simple terms. And that's what the definition says. A join allows us to retrieve data that is spread across multiple tables. And then it says, join clause is used to combine rows from 2 or more tables based on the related column between them. Yes, so when data is stored across multiple tables, there's always a column which is related, which is common. And on the basis of that, we join 2 tables. So that is what join does. Now, the question comes that, why do we have data in multiple tables? Why not just have everything in one table and then we'll not need join, right? That's also can be a question. Now, for that, the answer is that organizations store huge amount of data. And it's not always a good practice to store everything in one huge table. That will hurt your database. That's going to make your database lag. It's going to increase the redundancy. It's going to cause a lot of issues. And that's why organizations follow something called normalization. Now, what is normalization? In this process, you divide one big, huge table into multiple smaller tables. So that's what normalization does. If you read the definition, it says, instead of storing everything in one huge table, databases store information in multiple tables. And this process is called normalization. Normalization involves splitting a table into multiple tables. So instead of storing everything in one huge table, which is of course going to hurt a lot of things, which is going to disturb a lot of things, companies prefer to store things in multiple tables, and that process is called normalization. We'll deep dive in normalization some other day. Today's topic is not about normalization, so I don't want to waste a lot of time there. Okay, but just for example, I have stored one example. So before normalization, if you are just storing everything at one place, it looks something like that. You see, you have employee department table and you have everything in one table: employee ID, employee name, department location, employee skills. But after normalization, this one table has been split into 3 tables, and that is employee, department, and employee skills. When you look at from a different lens, you might think that, okay, I think before normalization, it looked simple because it had just one table and everything was stored in one table. But why did we need to split that one table into 3 and we made it complicated? But it looks simple when you have just 3 or 4 rows. When you see the small data, it might look good, but when you are dealing with millions and billions of rows, it's not a good idea. It's always good to split those tables into multiple tables. Now, why do we do it? How do we do it? We'll cover that in some other detailed session. For now, just know that since we have multiple tables and the data is stored in multiple tables, that's why we need joins to bring data from those multiple tables. Okay? So by now we have established that join brings data from multiple tables, right? Now there are total 6 kinds of joins, right? We have inner join, left join, right join, pull outer join, cross join, and self join. Just for your reference, I've added these images, but I understand that these images will not make sense right now. Unless you have understood what is each join, these images might look scary. So let's not get scared and let's start studying each join. So yeah, these are the 2 sample tables that I've taken, and these 2 tables we'll be using throughout this class, and we'll be taking these rows and these columns as an example when we understand joins, right? So look at these tables carefully, because coming 6 examples of joins depend upon these tables. Okay, so I want you to be very careful while looking at these tables. First table is of employees, which is also in short, we have given a short name E, and then we have departments. So we have these 2 tables. Employees have employee ID, employee name, and department ID. Okay. Generally, you'll have a lot of columns in employee data, but since it was just an example, so I'm not taking a big data. For now, we have employee ID, employee name, and department ID. And then in departments, we have department ID and department name. Now, notice one thing: we have department ID in both the tables. If you remember, when I was telling you the definition of join, I mentioned something The join clause is used to combine rows from two or more tables based on a related column between them. Based on a related column between them. So this is the related column that I was talking about. Now we need to join these two tables to bring any data, right? If you want something from employees and if you want something from department, you need to join these two tables. You will be joining on the basis of this related column. Okay, so this is the common column that we have. Now let's move forward with inner join. So first, do not read this definition, okay? Let's see this Venn diagram. You know, I think in school we have studied about Venn diagram, right? What does this Venn diagram say? It says that you have two tables, yeah, table 1 and table 2, and this join, whatever this is, in our case it's inner join, but whatever this join only cares about this part, the green part, means whatever is common between these two tables, that's what inner join cares about. Right? That's what this Venn diagram says, that I am only going to care about the matching part. So whatever is common between table 1 and table 2, that's what I'm going to care about. Right? Now let's read the definition of inner join. Inner join returns only rows that have matching values in both the tables. Okay? I think it was pretty clear from this Venn diagram when it showed green in the matching area. It said that I do not care about the other area. I just want to know that what is the matching value in both the tables. And that's what result I'm going to give. Now, let's see the syntax. It says that returns only matching rows from both tables. Yes, of course. And then let's again go back and see the table. So we had employee ID, employee name, department ID, and department name, right? Now, what are we trying to do? We are trying to bring the matching rows, correct? Just for you to recall, we had department ID 1 in both, we had department ID 2 in both, we had department ID 3 in both, but, do you see 4, department ID 4, do you see in this employees table? I don't see it, because it's not there. Again, do you see this department ID 5 in this department table? No, which means that only 1, 2, 3 exist in both the tables, right? 4 does not exist in employees table and 5 does not exist in departments table. That's what the data says, which means the question that inner join is going to solve, it's just going to give me the data about these 3 departments, because these are the only 3 departments that exist in both the tables, employees table and departments table. Now let's see how do we write the inner join. So first we write select statement, of course, and E means it was short for employees table, okay? Then we have E dot employee name, which means that from employee table, right, we are calling employee name because that's where employee name exists. We do not have employee name in department table, right? So that's why we are calling employee name from employee table and department name from department table, because we do not have department name in employee table, right? Do you see department name in this table? I don't see it because it's not there. Where is the department name? Department name is in department table, right? So what are we doing? We are calling employee name from employee table, department name from department table. You're writing from employees, okay? And then you are giving the short name of employee that you wanted to give. Then you write the join clause. You write inner join. You can even write join, that will not matter. It depends upon few of the databases accept inner join, few of the databases accept join as well. Okay, so inner join. Now, which table do you want to join with employees? I want to join the second table that I have, and which is departments table. So first we wrote the select statement and then we added the columns that we wanted to see in the output. Then we mentioned the first table, right? In from statement, we mentioned the first table, which was in our case employees, and then we wrote the join clause. Now after join, we are mentioning the second table that we wanted to join, which was departments in our case. And at the end, we write that common column on the basis of which we are going to join these two tables. What is that common in both the tables? Department ID was common, right? So this will be a common column on the basis of which we are going to join these two tables, right? That's why I wrote on. Remember this, we use on, and then we write E dot department ID means bring department ID from employee table and make it equal to department ID from department table. So now again, let's go back to the data. So it checks that I find this department ID 1 in employee table as well as in departments table. I'm going to give this result. Then it goes to the second. Then it says that, okay, I find the second department ID in employees table as well as in departments table. I'm going to give this an output. The same thing it does for third. Again, it finds in both the tables, it returns an output. Then it goes to null. It says, do I have null in here? I do not have null. So I'm not going to return that in my output. Then again, it checks for fifth. Do I have this department ID in the department table? No, I do not see that. So I am not going to return this row in the output. So at the end, what are the three rows that we had? We had this and this and this. And what were the columns that we called? We called employee name and department name. So who was the employee of the first department ID? It was John, right? And what was his department name? HR. So let's see, do we have that in result? We have it, John and HR. Simple, right? Then let's go again. The employee that belonged in department 2 was David. And what was his department name? It was finance. So David and finance. Do we have it? Yes, we have it. David and finance. Then comes the third, which is Sarah. Now Sarah's department ID was 3 and it was available in both the tables. That's why Sarah will be given in result as well. And what was the department name of Sarah? That was IT. So Sarah and IT. Let's see, do we have that? We have that in our output. And that's it. We got it. So these three rows were matching in both the tables, and that's why we only got these three rows in the output. So this is what inner join does. Now why again going back and forth to the table? Because when you understand your table clearly, that what is there in my table, which is column, where is null, then it becomes easy when you write the query, and it becomes easy when you get the output. You actually understand that why I got this and why I only got this, right? So I think that's clear now, that inner join gives the matching rows between two tables. And since John, David, Sarah, these are the three employees who had department ID 1, 2 and 3, and these three department IDs were common in two tables. That's why we only got these three employees and their department names. Done, right? So inner join is clear. Now let's move toward left join. This is the most used join, I think. So now we have a basic understanding of join, that what it does and how does inner join works. Just remember this word, this left, right, inner. This is going to be very helpful, and this is going to play an important role in understanding that which join does what. Okay. Again, let's not first read the definition. Let's go to the Venn diagram. What does it do? Remember, in inner join, the green part was only in the matching area, which was telling that I only care about the matching area. I do not care about the other areas. What's happening in left join? In left join, the matching area is already green, but there's something else which is also green, which is the whole left join. Okay, so we see something interesting, that this time we do not have just the matching area green. We have the whole table as green, which also includes the matching area, and the right and whatever left in the right table is not being considered. Right? Now we'll go to the definition of the left join, and it says the left join returns all rows from the left table, which we are actually seeing. The whole table is green, okay, and only the matched rows from the right table. Okay, so this is the reason why we have this matching part green and the rest of the right table is white, which means the left join only cares about the left table and the matching area or the matching data with right table. That's it. It doesn't care about anything. Okay, so first let's see the syntax. How have we written this left join? Again, we start with select, of course. We call the columns. So we want employee name from employee table, and then we want department name from department table. We are calling the columns. Now, we want, which is our left table? In question, the left table was employees, and that's why we have written the employee table first. Okay, from first table was employees. In this case, it's not mandatory. It totally depends upon what do you want. Okay, currently we want everything from employees table. That's why employees goes before left. Before left join, we have to write employees table. That's it. It can come after left join as well. If you wanted everything from department table, you'll just have to swap the tables. That's it. So how am I writing? First select, call the columns, then from, then the table that you want everything. We want everything from employees, so we have written employees, then left join. Okay, we, of course, if you remember, even in inner join, we have written after from, we have written the join clause, right? We are doing the same thing in left join. So the join clause, and then the other table. What was the other table? The other table was departments. So after left join, we are writing departments, and then we write the common column on the basis of which we are going to join these two tables. What is that common column? The common column was department ID. If you remember, what was common between these two tables? It was department ID. So we are going to write the same column on E.department ID is equal to T.department ID. Simple, right? Now what happens? Let's go back to the table and see. Now, since you are writing left join, which brings everything from the left table, which was our left table? Our left table in this case was employees, right? So, which means all the rows from employees table will be brought in the output. How many rows do we have in employees table? We have 5 rows. There's. We have 5 rows, which means all the rows of employees table will be visible in output. But what about departments? Let's understand. Which is common between employees and departments that will be visible in the result, right? So we are calling employee name. What all employees name that we are going to see in the output? All of them, because employees table is the left table. So we'll see John, David, Sarah, Mike, Emma, all of them in the output, right? But from right table, which is departments table, what all are we going to get? Only the matching values. Remember the Venn diagram? It does not take everything from the right table. It only takes the matching value from the right table. Okay, now what are the matching values? We just saw when we were looking at inner join, we saw that we only have 1, 2, and 3. These 3 department IDs are available in both the tables. So from department table, we are only going to get respective department name of department ID 1, 2, and 3, which means John's department will be HR, David, Finance, Sarah, IT, Mike. What about Mike? What is the department ID of Mike? None. We don't even know what is department ID of Mike. Then how are we going to map it with the right table? We can't, right? So Mike employee name will appear. Why? Because the employee name is coming from the left table, which is employees table, but Mike's department will not appear because SQL could not find Mike's department in the right table, right? So in front of Mike, we'll see none. Let's check. Yes, we see in front of Mike, we see null because Mike's department was not available in the departments table, right? Then comes Emma. Fine. Emma's department ID is 5. Now this 5 will go and look for 5 in the departments table. Do we have 5 in departments table? No, we do not have. So now Emma name will appear, but will Emma's department appear? No, it will not, because SQL was not able to find Emma's department in departments table. So in front of Emma, we'll see null. Do we have null? Let's check. We have null, right? So we got all the names from left table, which was employees table, but we only got 3 department, which was HR, Finance, IT, because these 3 were matching in both. For Mike and Emma, there was no matching detail. That's why we got null from the right table. Remember the definition? Everything from left table. Everything from left table. Only matching from right table. Only matching from right table. Simple. And whatever didn't match, it simply is true, none. So that's how left join works. Fine? Clear? Now just reverse it. Do not do anything, just reverse it and you'll get your right join. Look at the Venn diagram. Whatever you saw in left join, it just became opposite. So now you get everything from right table and only matching data from left table. Now left table is not given main priority. Which is the main table? Right table, right? And the definition says the right join returns all rows from the right table, which is department, and only the matched rows from the left table. It's exactly same, just ulta, opposite. Let's see the syntax. We are calling employee name and department name as usual. Now from employees, right join departments. Now remember, departments will be the main table in this. Why? Because this is coming after right. So whichever table comes after right, in right join, that table becomes the main table. Remember, when it was left join, which table was coming before left join, that table was important, right? Now in right join, whichever table comes after right, that becomes important. That becomes main, okay? And same, we are joining on the basis of department ID because that is the common column. Now let's understand, I want you to visualize the result. I do not want you to just, whenever output comes, you rely on the output. What if output is wrong? What if you wrote something wrong? That is one thing I want you to build inside yourself. When you actually imagine the result, that this should be the result. If I'm writing this should be the result. If anything else do you see, a red flag should come in your head that, okay, something is wrong. Maybe I've written something wrong, right? Then you go back and check the query. So that's what an ability that you should bring. Let's see what is going to happen for that. Always have the table open in front of you. Now, which table is important? Departments, right? Because we are using right join, and to the right of the right join, we have departments table. Now, what was the first thing in the right join? That it is going to take all the rows from right join, all the rows. That's it. So, which means we'll have 4 rows for sure. We're going to get 1, 2, 3, 4. Done? Rows clear. We are going to get HR, finance, IT, marketing. We're going to get these 4 rows. Now, who gets what? Now let's see, what do we get from left table, which is employees table. Department ID 1, which is department ID. This is 1, so we'll get John. Okay, so John and HR will appear. Department ID 2, again we have David and finance. David and finance will appear. Department ID 3, we have common, so Sarah and IT will appear because these were matching. 4, no matter if it matches in the left table or not, we are anyway going to get it. Why? Because this is the main table, and the main table has 4 rows. We have to get 4 rows in output. So this 4 department ID, which is marketing department name, this is going to appear in your output. But do we have the employee name of this department ID? Let's check. 4, do we have 4? No, we do not have 4 department ID in employees table. So what will happen? You will get marketing, but in front of marketing, in the column of employee name, you'll get null. Do we have it? Let's check. John, David, Sarah, and in front of marketing, we do not have anything, right? Because this department ID was not common in both the tables, and that's why, since the department table was the main table, we got everything from department table, but we did not have any common thing in left table, which is employee table, we got null. Simple, right? Just ulta of left join. No brainer. So we're done with inner join, left join, and right join. Now comes full outer join. Look at the Venn diagram. Do not look at the definition. What does this Venn diagram say? It says everything is green, right? Everything is green here, which means it takes everything. Simple. That's what pattern we have seen till now, right? Whichever was green was considered in the output. In inner join, the matching was green and the matching data was considered in the output. In left join, this part was green and it was considered in output. Right join, the same. Full outer join shows everything green, which means everything will be considered. Simple. Let's see the definition. Are we getting it right? Full outer join is used to combine the results of both left join and right join. Exactly. Now the syntax remains same. First, select and you call the columns, and then you write the first table, then you write the join clause, then you call the other table, and then at the end you write the basis on which you are joining. Syntax remains same, but we'll have to worry about the output. Now do me a favor and do not cheat. Do not see this output. Do not. Go back to the table and visualize the output in your head. Okay, let's see. We are telling that full outer join gives left join result and right join results. Let's see. What does it mean? It means that you'll get all the rows from left join and all the rows from right joins. And wherever there's no matching, it will simply show none. That's what full outer join does, which means that we have department ID 1, 2, 3, null 5. We'll get all of it. All of it. So what will happen? The 1 will go search 1. Okay, I got it. John, HR, fix. David, finance, fix. Sarah, IT, fix. Then comes Mike. Mike's department ID is null. We cannot find it in departments. But still, since we are using full outer join, Mike will be available in the output as well. But the question is, okay, Mike will be there, but what will be Mike's department? Null. Simple. Because you could not find Mike's department in the departments table. That's why you are giving null. Okay. Then we have 5. And Which is employee for department ID 5? Emma. What is the department of Emma? I don't know. Fine, give null, right? But you have to call Emma in the output as well because it is full outer join. So we have considered all the rows from employees table. Now let's go back to departments table. Have we considered 1? We have already considered 1. We have already considered 2. 3 is also considered. 4. 4th was not considered because 4th was not found in the left table. But do we need to consider 4? Of course we need to consider 4 because this is full outer join and it wants everything. Okay, fine. I agree with you that it's full outer join and we are going to consider everything. But what will be the employee name of this department? Because we do not have the respective employee name in the employees table. So what are we going to write in that? We are going to write null because that is true that we do not have any matching row in both the tables for this department ID. So what? We will show this department name. We'll just write null in front of marketing. Let's see the output. Is it what we just studied? John, HR, David, Finance, Sarah, IT. Because these three were matching. Mike's and Emma's department detail was not available in department table. Did we forget Mike and Emma? No, we brought Mike and Emma as well. And since we did not know what is the department of Mike and Emma, we wrote null. Again, the same thing. We had to bring everything from departments table as well. And in that, 3 departments were already done. Only department was left, which was marketing. But we did not have employees detail of this department. What we did? We simply gave null. But notice, we gave null, but we brought all the rows. And this is the message that this Venn diagram was trying to give. That bring everything. No matter if it's matching, not matching, just give null and bring everything. Okay? So, done with full outer join. Let's move toward cross join. This is different. This is a little different, Now, how it is different, let's understand. See Venn diagram. I want you to look at this carefully, okay? Do not read the definition. Do not see the syntax. Understand the concept. Let's see what's happening in the diagram. 1. From 1, we have 3 arrows coming out. 1 is going towards A, 1 is going towards B, and 3rd is going towards C, right? The same thing is happening with 2. 3 arrows are coming from 2 and it's going and matching with all the things in table B. Same thing is happening with 3 as well. 3 arrows are coming and going matching with everything. This says a very important point. It says the same thing that you're going to read in definition now. What is the definition? It says a cross join in SQL combines every row from one table with every row from another table. This is very important. Every row of table A will be joined with every row of table B. Means for 1, there will be 3 results. 1 joined with A, 1 joined with B, 1 joined with C. Again, for 2, there will be 3 results. 2 joined with A, 2 joined with B, 2 joined with C. Similarly, there will be 3 results for 3. 3 joined with A, 3 joined with B, 3 joined with C. Which means we had 9 rows, right? 3 for 1, 3 for 2, and 3 for 3. So 3, 3, 3. 9 rows we have created, right? And this is what the definition is trying to say. A cross join in SQL combines every row from one table with every row from another table. It results in a Cartesian product, meaning if table A has n number of rows and table B has m number of rows, the output will be n into m. Let's see. I told you that this will result in 9 rows. It will, because we have 3 rows in table A and 3 rows in table B. And if this join produce 3 rows for every row, then of course we are going to have 3, 3, 3. 3 plus 3 plus 3, 9. And 3 into 3 is also going to be 9. So that's how you calculate. It becomes a very important concept and very important interview question as well. Let's go back to the data and see what's happening there. Yes. So now how many rows do you have in employees table? 5, right? And how many rows do you have in departments table? 4, which means you are going to get 20 rows. So how does it work? Now this department ID from employee will go and join with all of the rows of the department ID. So how many rows did you have in output now? 4. Again, the same thing department ID 2 will do. So you have 4 more rows. How many rows? 4, 4, 8. Again, the same thing department ID 3 will do. 4, 4, 8, 4, 12. This null will again produce the 4 more rows. Again, you have 16. And then comes 5 will do the same thing and you have 4 more. So you have total of 20 rows in your output. So this is how many rows cross join produces. And you might get asked this in your interview, that how many rows cross join produces. So all you have to do is take the number of rows of column A, take the number of rows of column B and multiply them. That's it. So in this case, what was the result? How many rows were there in the result? 20, right? And if you also multiply this 5 into 4, what is that? 20, right? So that is the result. We're done with this. Now the last join is self join. I think it's pretty clear from its name that it joins with itself. Okay, it does not have two tables. That's why I have taken this one table. So we are not going to refer the other two tables in this case, because self join joins with itself. That's why the definition says that a self join is a regular join, but the table is joined with itself. Other things work exactly like the other joins. Just one thing, that you do not need two different tables for this join. You just need one table and you join it with itself. Generally, employee manager questions are solved with the help of self join, which we'll do in the later sessions. But just so you know that we do not need two different sessions, because of course it says self join. I'm going to join with myself. So that's what self join does. Okay, I think syntax is clear. Now do not get confused with this left join word. Okay, don't think that I have to write self here. Do I need to write self here? No. Self join is a concept, it's not a clause. So you will write left join only. It's just think that you are just joining employees table with employees table. That's it. You have given two different aliases. So in one place you have given E and in the other place you have given M, but you are actually joining the same table with each other. That's it. And this will be your output. So it's a little, self-join is kind of tough, and you'll understand it when you have the concept of other joins clear in your head. So I'll not jump on making you understand self-join. I want you to first go through the concept of all other joins. Once you are done with this, then we'll be well versed to understand self-join. Now, one thing I forgot to tell you that in cross-join, if you notice that we do not have on clause here, this was intentional, this was not a mistake. In cross-join, you do not need on. Right? Of course, because it doesn't care that do we have anything matching. I don't care. I'm anyway going to join with all the rows with the table, right? And that's why we do not have on clause in cross join. I have just created this one table. If you want to take screenshot, you can take. This will just help you when you are revising for your interviews, or you just want to quick recall the concepts. Just take a screenshot if it helps you. And that's it. I think you found it useful. You understood the join concept, at least theoretically, because I've not covered any writing query part. We'll do it later. I want you to sync these concepts and then we'll jump on writing queries, solving problems. We'll do that in later sessions, okay? Watch this video, practice hard, try to understand what's going on, and meet me in the next session. Bye-bye.